numericals of exercise 2A, the cancellations are 1, 5, 9, and the IMP sums are 4, 6, 10, and 16. Check that the questions are same in your book because my textbook is old. Now let's discuss the fourth sum. 3 speeds are given in different units. We have to arrange them in increasing order, that is smaller to bigger. To compare, we'll have to convert all of them into the same units. Let's convert them into the SI unit, which is meters per second. So the first one is 10 meters per second. The second one, let's convert it to meters per second. And the third one, 2. To convert kilometers per hour to meters per second is easy, just multiply by 5 upon 18. And now we see that this is the smallest speed. So now we can arrange them in the increasing order. Now the sixth sum is similar to a math problem. We've got two cases. Distance is same, 30 kilometers and 30 kilometers, but the speeds are different, 60 kilometers per hour and then 40 kilometers per hour. Roman number 1, they want the total time. So I feel that the table method is the easiest way to write it down. Speeds are mentioned, the distance is the same. We'll find the time individually. Half an hour here and 3 upon 4 hours here. They want the total time, so let's add them. They are fractions, find the LCM and I get the answer. But we should not leave the answer as a mixed fraction or an improper fraction. Ideally, we should convert it into a better unit. So here, let's convert it to minutes. So we get 75 minutes as the answer. Now, Roman number 2, average speed, that is total distance upon total time. Total distance is 60 kilometers and time, let's take the hours value, not the minutes value, so that we get the final answer in kilometers per hour. Now in question 10, a car starting from rest. Rest means initial velocity 0. Acquires a velocity of 180 meters per second. That's the final velocity. Time is in hours. We'll convert it to seconds. Find the acceleration using the formula. So in the solution, U is given, V is given, time we've converted to seconds. Use the formula of A and we get the answer in meters per second square. In the 13th sum, the car's acceleration is given 5 meters per second square. If it was deceleration, then we would have written A is equal to minus 5. But here it's the normal acceleration, so A is equal to 5 meters per second square. Time is given and increase in velocity is given. Increase in velocity is nothing but V minus U, that is final velocity minus initial velocity. So we will use the direct formula here. A is given, T is given. Use the formula to get the answer of V minus U, which is the increase in velocity, that is a change in velocity. Question 16 is IMP. A car is moving in a straight line where the speed is 18 kilometers per hour. So that's the initial velocity U. We'll have to convert that into meters per second. It is stopped. That means the final velocity V is equal to 0. Time is given as well. Roman number 1, find the speed of the car. So here we found the speed of the car, which is 5 meters per second. Roman number 2, find the retardation. So we find the acceleration using the usual formula, but we get a negative answer as expected because there is a deceleration here. When we write the final statement, retardation is equal to 1 meter per second square, do not write the negative sign. Roman number 3 says, what will be the velocity after 2 seconds? It stopped after 5 seconds, but what if we wanted to know the velocity after 2 seconds? To calculate velocity, we just cross multiply this same formula and get V alone. So we get this new formula, V is equal to U plus AT. This is the same as this formula. Now initial velocity was 5. Acceleration we have calculated is minus 1. Don't forget the minus sign here. And the new time is 2 seconds as per Roman number 3. So on solving, we get the value as 3 meters per second.
Hi students, this is AJ sir. If you like this video, press the like button. If you would like to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information.